Imagine trying to do machine learning, but without fast mathematical computations. That is where NumPy comes in. In this video, I will explain you what is NumPy, why it's important, and the absolute basics you need to start using it today. So the first question is, what is NumPy? NumPy stands for Numerical Python. It is a very fundamental library which is used for mathematical operations, linear algebra, working with arrays, and scientific computing. Almost every major data science or machine learning library uses NumPy under the hood. So if you understand NumPy, you understand the foundations. Now the second question that arises is, why not use Python lists and use NumPy instead? So Python lists are flexible, but they are slow for mathematical computations. NumPy arrays are faster, use lesser memory, and they support vectorized operations. Now let's start coding and understand NumPy through code. So NumPy is a fundamental library in Python used for scientific computing. It provides support for arrays, matrices, and a collection of mathematical operations on these data structures. So the very first thing we'll do is we'll import NumPy as NP. NP is an alias used for NumPy so that we don't have to write NumPy again and again. If your system does not have NumPy, you can use the command in the terminal pip install NumPy and it will install NumPy for you. For me, the requirement is already satisfied since I've already installed NumPy. I've also created a virtual environment here if you can see, and I have put the requirements in my requirement.txt file. I'll explain this in some other video. Let's create a 1D array using NumPy. To create a 1D array, what we'll do is we'll write ar is equal to np.array 1 2 3 4 5 and print the array. So this will create a 1D array. We'll print the shape and we can see that this is a 1D array because it just shows 5 comma nothing at all. We can reshape it into a 2D array and it will give me the answer in double brackets. That is, now it is a 2D array. I can reshape it similarly into 5 rows and 1 column. Another way to generate the array in NumPy is using the arange function. np.arange 1 comma 10, and I can use the reshape value similarly here as well in front of by putting in front of it by putting dot reshape 9 comma 1, and it will give me an array of 9 rows and 1 column. I can generate an array of ones as well using np.ones, and I can give the size here. Here now I'll give the size 3 comma 4, and it will create a matrix of all one values. Uh, it will create an array of all one values, a matrix kind of array with the size as 3 rows and 4 columns. I can similarly create an array of zeros by using np.zeros 4 comma 5, and it will create me the similar an array of 0 values similarly. I can also create an identity matrix using NumPy by using the function .I, that is np.I, and I have since the identity matrix are square matrix, so I will give only one attribute, that is 3. I can change it to 6 and it will give me an identity matrix with 6 columns and 6 rows. What is an identity matrix? I'll explain. An identity matrix is a matrix where all the diagonal elements are ones and all the other elements are zeros. These matrices are very useful in data science, so we'll use it later on when we'll study the further in data science. Okay, now let's create an array which is 3 comma 3 in size. I have created an array of 3 comma 3, 1 2 3 4 5 6 7 8 9 as the elements, and printed the array. I'll print it again, and I'll print the shape, and printing the shape will give me 3 comma 3 only. I can print the dimension of the array. The dimension is 2. As you can see, there are double brackets, so the dimension of the array is 2 only.
I can also print the size of the array, that is the number of elements of the array, and I can also print the data type of the array. The data type varies from machine to machine. For your machine it might be int32, for my machine it is int64. I can also print the item size in bytes by using arr.itemSize, and it will give you the answer. This is also different for different machines. Now we'll see some NumPy vectorized operations. I have created two arrays here, 1, 2, 3, 4, 5 and 10, 20, 30, 40 and 50. Now NumPy is better than lists in Python because it goes element wise only. It automatically does the operation element wise. In list you have to traverse through the list and then add the elements, but in NumPy arrays it automatically goes element wise and adds it for you. So I have given element wise addition, element wise subtraction, element wise multiplication and element wise division here using simple commands as r plus 2, r1 plus r2, r1 minus r2, r1 into r2 and r1 divided by r2, and it has given me the answer element wise. Now we'll go to some universal functions in arrays which applies to all the elements in arrays. So some universal functions I have covered here are square root, np.sqrt, np.exponential, finding the exponential value, finding the sine value, finding the log value and finding the cos value. I'll run this and it will give me all the values. Now we'll go to array slicing and indexing. So array slicing and indexing is a very interesting concept. I have created a 4,4 array here, and now we'll do some slicing and indexing which will be very interesting. First of all, to extract just the first element, what I'll do is that I'll write 0, 0 because indexing starts from 0 in Python. So I have written 0, 0 and it gives me 1 as the element. Now what if I need 7, 8, 11 and 12? To take 7, 8, 11 and 12, I need to look at the row and the column. Just mind the row and the column. See, it is in the first row. Through indexing it is in the first row, and uh, second row, but not in the third row. So I'll give 1 colon 3 so that it doesn't print the third row, and I'll also give uh, 2 2 colon so it prints me 7, 8, 11 and 12. The column will be 2 and 3. So 1 colon 3 and 2 colon gives me 7, 8, 11 and 12. Similarly, you can pick 3, 4, 7, 8 by going uh, to the 0th row, 3 and 4. It will give you the, I just want the first and the second row. So I have done 0 colon 2. So it doesn't print the last number, it just prints up to the last number. So it has given me the first and second row, that is 1 2 3 4 5 6 7 8. Now I need to pick the columns, and the columns are 2 colon, and it will give me 3 4 7 and 8. Similarly you can pick 6 7 10 11, which are the center elements. So it is 1 colon 3 comma 1 colon 3. I can also change and modify the values using indexing by writing arr 0 comma 0 is equal to 100. I have changed the value of the array's first element to 100. Similarly, I can change multiple values using arr 1 colon, like I want all the values from the first row to all the values from the first row to all the other values as 100. So I have written 1 colon and it will change the values to 100 for all the other rows. Now let's go to some statistical concepts, that is normalization, mean, median, standard deviation and variance. First we'll create an array and calculate the mean. To calculate the mean we'll simply use the function np.mean of array, and for standard deviation we'll simply use np.std. Normalization of a data is actually a data. Normalized data is a data is that is having a mean of 0 and a standard deviation of 1. So the formula for it would be array minus mean divided by standard deviation. So the normalized array would be array minus mean divided by standard deviation, and this will give me the normalized array. You can see that the mean is 0 but standard deviation is 1. We'll have to check. Now calculating the mean and the calculating the median and variance is also very easy. You can simply use the function dot median array and you can print the median, and for variance you can use dot var and you can print the variance. Now let's go to logical operations on array. So logical operations are some very interesting operations where you actually print the values based on your logical operators. Like I have used ar greater than equal to 5 for this array, for this particular array. So it has given me false for all the values which are less than 5 and true for all the values which are greater than or equal to 5. I can combine this into uh, giving me the values like using the square brackets and then using not the curly braces, the normal brackets, like writing array greater than equal to 5 and array less than equal to 8. This will give me the numbers between 5 and 8 including 5 and 8. This is how you can do logical operations as well on arrays using NumPy. So that is all from my side. We'll look into NumPy more in the upcoming videos, but these are all the basics, and I hope that I have made everything very clear. If you have still any doubts, you can write down in the comment section, and I will definitely answer them.